Everyone, welcome back to my channel. In today's video, we will diving into some super, let's say, important aspect or important stuff in machine learning, which is loss function in neural network. So think of it as GPS guiding your model in the right direction. So this is how the let's see the loss function. And what is the loss function indeed? So assume that you have a deep learning algorithm is running, right? And you have let's say your training data, and you would like to build a model, let's say a high performance model. So now this is your data, and after feeding this data into the model will try to update itself. I mean the parameter, of course. So based on this, I mean the calculating the loss function will let the neural network to update the weights. So in that case, you will have, let's say, a good performance. So what is the loss function itself? It's a quantitative quantifies how will a neural network perform or perform, yes, and and it's compare between the your predictions and the actual result. And the best part of it is turn these mistake into a numbers, which your model can use to learn and improving over time. So let's say, for instance, in this example here, why it's important. Let's say, for instance, your model is trying to predict the house prices. Now I have added here only one parameter here. Let's see, because for the house pricing you need many variables or attributes. And let's see just here the input of the size of the house, and here's the actual price, and this is the predicted price. Now the loss function is trying to measure the difference between predicted price and the actual price, and see if it's big, the model needs to be updated. Let's say the parameters needs to be updated. So these parameters already explained in the previous videos. Please have a look. And also in many several algorithms, already explained in many several algorithms like XGBoost, support for machine linear regression, also logistic regression. Now let's see, for instance, I have this actual price, and this is a predicted price. Now calculating the error with prediction minus the actual. This is, for instance, 20,000. And with applying the mean square error, we will try to square this error here. So as you can see here, this is a big number, and this let you that you that is a huge, let's see, error. But now how the model know how far it was. So, and based on this value, it will try to update the parameters of the network. So this loss, let's see, for the upcoming, let's see, iterations or epochs, this will be somehow close to zero. I mean, the optimal value is to be the optimal error. It should be, let's see, zero. For instance, the actual price is 300,000, and let's say the predicted thousand, the optimal case, it will be 300,000, but it will be plus minus something. And until you have, let's say, agreed with this or satisfied with the model, this is, for instance, enough for the model. Now there are several or important loss functions used for the in the deep learning in the deep learning. The first one is mean square error. It's a great for regression, and but it's it's try to, let's see, if your data is having only let's see, numerical values, like for instance predicting house, it use only for the for this for values that is numerical. And also the mean square error, it's the same as this one here. And binary cross entropy, it's used for classification. For the classification, if you have, for instance, cat or dog, here you need is only a binary classification, for instance. And the hang loss, it's used, if you remember, it's used for the in support vector machine. This is with the regularization function. And this already explained in a very easy way with a numerical example. So please have a look in the support vector machine. And now let's have a look on type of loss function. I mean, this is only the loss function, but we need to know when to use this and when not. Let's say, for instance, mean square error is used for regression problems. When you have numbers, the target value is number. For instance, house pricing is a numbers. And let's see, forecasting, weather forecasting, it's predicting the degree, the temperature, it's a number. So we need to use mean square error, or maybe mean absolute error. And binary classification, binary cross entropy, it's used for binary classification. And if you have a spam file, spam, email, spam, or ham, only two classes you have. And categorical cross entropy if you have multi classes. For instance, if you have, as you can see here, for instance, predicting the digits between 0 and 1, or maybe if you have a let's see, ImageNet that has 80, for instance, or maybe then 80 classes for the animals. So in this case, you need to use categorical entropy, cross entropy. And the hang loss is, as you can see, it's support vector machine classification. And let me just see, I have also provided this, and it's somehow this is what we have already explained, but in a PyTorch framework, or let's see, package. And here you have the mean square error. This is how to import the mean square error. The error is, for instance, here. And here's the mean absolute error, and the loss, Hooper loss function, and binary cross entropy. For instance, you have the prediction, and you have the truth. So, for instance, 0.9, and here's 1. And the binary cross entropy, this is calculated by this function, or let's see, class. And here you see the binary says binary loss except for digits. And here the categorical cross entropy, if you have, let's see, multi classes, as we already said. And the last one is the for the hang loss. It's not, let's say, provided directly in the PyTorch. It's not available, so that's why you have implemented here. Also, this was already implemented in a support vector machine, and you can see it in support vector machine. I don't know where is it, but it should be here. Yeah, that's it for today. And if you like this video, please subscribe into my channel and like this video. And if you have, of course, any question, please drop it down in the comment below. Thanks for watching, and see you next time.